So next is factoring by grouping. And so this is shown at the very end of the section, but I actually show it now because there's a method that I use for factoring that the book does not teach that I actually prefer. And so in order to show you that method, we have to learn factoring by grouping first. And so this is used when you have 4 terms specifically. And so the steps are that you first factor the greatest common factor from 4 terms, if there is one, sometimes there's not. And then you group things together in pairs. So you group the first 2 and you group the last 2 and you put parentheses around each of those. And then you look at each pair and factor out the GCF of the pair. And then you're going to be left with something with a binomial factor, which is actually, oops, it went too far. Something like the left example here, where you have a binomial factor, you're going to be left with something that looks kind of like that, and then you're going to factor that out. So it's like you're factoring multiple times, but it's a really nice method for when you start getting into trinomials. So here's how it works. So first, you look for the GCF. So in this case, if I look at all of the numbers, I have a 1, a 5, and a 25. So if I had a 5 in front, then I would have a GCF of 5. But because of that 1, my GCF is going to be 1. And then I have x cubed, x squared, x, but then I have something without an x. So I can't take out an x either. So if my GCF is 1, then I'm not even going to factor that out because it's not going to change anything. And so then we go to the grouping process. So you take the first 2 terms and you group them with parentheses. And then you do the same thing with the last 2. And if you have that minus there, you're always going to put plus and then put the minus in the group. So we always want to make sure that we have a plus sign between the 2 groups. So if there's a subtraction in that 3rd term, it turns into adding a negative. So now we've got pairs. And so now we want to find the GCF of each pair. So the first pair, number-wise, I'm looking at 1 and 5, so I can't divide out a number because that would just be 1. But I have x cubed and x squared, so my GCF is going to be x squared since that's the smallest exponent. The second pair, I have 5 and 25, so 5 is the largest number I can divide out, and because I'm negative there, I'm going to factor out a negative 5 because that first one is negative. And then I have an x but something without an x, so I can't factor out an x. So now I've got 2 different GCFs because we're looking at each pair separately. Now I want to factor the GCF out of each pair. So for the first pair, I've got my x squared, then x cubed over x squared plus 5x squared over x squared. And then my second one, I have plus negative 5, and then I have negative 5x over negative 5. And then this is another case where I would take that minus 25 and add it as a negative 25 because I'm dividing by negative. So now that I've written this, now I need to simplify inside each set of parentheses. So I have x squared outside, and then when I subtract the exponents, x cubed over x squared gives me an x. And then my x squareds cancel and I'm left with 5. Now I'm going to just write this plus negative 5 as a minus 5. And now negative 5 divided by negative 5 is 1, so all I'm left with is an x. And then negative 25 divided by negative 5 is a positive 5. So what's special about the grouping process is that if you do it correctly, you are going to end up with the same thing in the sets of parentheses. So if you've done it correctly, you will end up with identical things in the set of parentheses. And that means you can factor those out. So that would mean going through the process again, where you have to put that in parentheses, and then what's remaining in the sets of parentheses, simplify. But because we know that they're going to match, there's a little shortcut where you can just say, okay, I'm going to have x plus 5 in front because that's what's in common. And then when you remove that, you're left with the x squared minus 5, what is basically left over. So you can kind of skip the step where you have to write all the parentheses in the dividing because of the fact that they're identical and you don't have to worry about any exponents and things like that. So you always end up with what's the same being your first factor, and then what's left over being your second factor. So the whole reason we want to pull that -5 is because if we didn't, when we get to the factoring step, we would have had a negative x minus 5 on that side, and then they won't match. So that's one of the other reasons that we like to pull a negative, or that first one is negative, because if you don't, you're not going to have things that match, and then you can't really go further. Okay, so here's another example, and this one has a GCF, so I wanted to show you what it looks like if you factor out the GCF first. Then you have to be very careful because you have parentheses up with the wazoo. So first we look for the GCF, and in this case it's just a number because the 10 doesn't have a variable, so I can't factor anything out. Actually, my F looks terrible there. So out of 6, 2, 30, and 10, the biggest number I can divide out of all 4 numbers is 2. So my GCF here is going to be 2. For the sake of trying to save space here, especially if all I'm doing is dividing out of 2, I'm going to do this mentally. So I'm just dividing 2 out of every number, which leaves me 3x cubed plus x squared minus 15x minus 5. So if the GCF is just a number, it's really easy to skip the step in between because all you're doing is dividing that number out. So now we need to do the grouping process where I'm going to pair things together. So this is where we get lost in the parentheses. So you want to be very careful here. I don't know if like color coding, or you can even use brackets instead of parentheses to help, whatever works for you. So I've got my group, my 3x cubed plus x squared. And actually, you know what? I think I'm going to do brackets to help make that less confusing there. And now my third term has a negative, so I need to always have a plus there. So I'm going to put a plus and then negative 15x minus 5. And then I'm going to close my bracket. So now I want to find the GCF out of each pair. And so the first pair, I've got numbers 3 and 1, so they don't have anything in common but a 1. And then I have an x cubed and an x squared, so my GCF is going to be x squared. Second pair, GCF is going to be negative 5 again, because my first term is negative because I have a negative 15, and then 5 is the largest number that divides out of both of those. So now I have 2, bracket. Now everything is going on inside the brackets, so I'm going to put my GCF and then do my division stuff. So this is one of the reasons why, if you can get to the point where you can do this mentally, it's really nice, because then you don't have many parentheses and all that stuff going on. Because if you do it mentally, it will take fewer steps and you don't have to write as much stuff. So that minus 5, I'm adding a negative 5 because I'm dividing by a negative. Okay. So next step, my 2 still hangs out in front. I've got my bracket. I've got my x squared. And then I need to simplify. So I have a 3. And then when I subtract the exponents, 3 minus 2 is 1, so I have a single x. Now, x squared over x squared. Those completely cancel. We're dividing those, so it's not 0, it's 1. a common error I see is people see, oh, they cancel, I get a 0 there, and they don't write it. But no, there's still a term there. We're dividing. So when you have things that divide and they're identical, your answer is 1, not 0. Then I have my minus 5, parenthesis. Negative 15 divided by negative 5 is a positive 3, so I have 3x. And then negative 5 divided by negative 5 is 1. So once again, I have plus 1. So we know we haven't made any mistakes because I have 3x plus 1 in both sets of parentheses. So now my 2 stays in front. And now at this point, you can lose the brackets. So now what's in common in the parentheses is 3x plus 1. So I'm going to write 3x plus 1. Oops. And then what's in front of those are x squared minus 5. So then I have x squared minus 5. And now is completely factored. So if you end up having a GCF, all it does is hang out in the front and just follows you along until the very end.